So in this video, I want to spend some time to talk about the arc length, and essentially, it's nothing more difficult. It's just the idea of remembering the formula and doing the integration. Now, essentially, what it's saying is, if we have some function y is equal to f of x, and it is a smooth curve on the integral from a to b, then the arc length is given by from a to b. The integral from a to b of 1 plus f prime, the derivative of that function squared, and we take the square root of that. And the same is true for the y sort of function. Okay, so let's look at an example. So what if we wanted to find the arc length of f of x is equal to 2/3 x squared plus 1 to 3/2. Okay, on the interval of 1 to 4. Well, there are limits of integration. So the first thing I usually do is just do everything by hand before I plug into my formula. Okay, and so the first thing you should do is take the derivative. So if I'm taking the derivative of this function, I know 2/3 is a constant, so it stays out there. I'm going to bring this down, so this becomes 3/2, okay, times x squared plus 1. Well, if I take 1 minus this will give me 1/2. Okay, so that will give me 1/2. And now remember the chain rule, so I gotta multiply this by the derivative of the inside. So if I multiply this by the derivative of the inside, derivative of 2x is x squared is just 2x. Derivative of 1 is 0. So there's our derivative. Well, this looks to me that these will cancel out. Okay. And so that being said, my f prime of x will actually be 2x times x squared plus 1 raised to the 1/2. Okay. Now, the formula says I gotta square this. Okay, so I gotta square this. So if I square this whole thing, okay, if I square this whole thing, then I'm looking at something like this. Well, 2x squared, that was just 4x squared. And again, remember we're if we were squaring, essentially what we're doing is that we're multiplying our exponents. Okay, so we're multiplying our exponents in this case. So this is x squared plus 1, and 2 times 1/2. Well, that's just 1. So that is this. So this is my derivative squared, and the function the formula just says I should just attach 1 onto that. So if I look at this, well, remember I could go ahead and distribute this even more. So my f prime of x will actually be 4x to the 4th, okay, plus 4x squared plus 1. Okay, so this is my whole thing now that I got to plug into my plug in for my my arc length. Now bear in mind this one is just that I attached. So this is my derivative. I just attached the one just to put everything together. And so I know my arc length is going to given by, okay, well, it's 1 to 4. So this is from 1 to 4 of the square root now of 4x to the 4th plus 4x squared plus 1 dx. Okay, now this is where it becomes very tricky. Okay, and for most of the arc length business that I've dealt with so far, the idea is that when you get to this point, you want to write whatever is under the square root in terms of a squared function. And the reason why you do that is because you're going to be able to lose your square root. Okay, and so it looks to me is that I could write this as 1 to the 4th of the square root of, well, this will be 2x squared plus 1. Okay, and I square this. Okay, so again, this is the tricky part. For most of the arc length functions that I deal with, at this point, you want to write everything on the square root squared. And so you could actually see that if I factor this out, I will get exactly the same thing. And so what this enables me to do is that this becomes integral from 1 to 4 of just 2x squared plus 1 dx. Okay, because I have a squared and I have a square root, so they will cancel out. Okay, so with that being said, now my arc length just becomes a simple business. And so if I'm looking at this, and then my arc length is going to be given by, well, what's the integral of 2x squared? Well, that's interesting. Well, if I take 2, x squared is just x cubed over 3, plus what's the integral of 1? That's just x, and we're only going to take this evaluated from 1 to 4. Okay, so let me kind of slide this paper on under here. Okay, So that being said, all we just do is plug and chug. Okay. So this becomes 2/3 4 cubed plus 4. Okay. And we're gonna also subtract this from 2/3 times 1 to the cube plus 1. Okay. So we should know by now that if I take 4 and cube it, I get 64. If I multiply 64 by 2, I get what? 128. So this will be one. Okay, hopefully you could see. So this now will be 128 over 3 plus 4. Okay, so the 128 over 3 plus 4. Okay, and we're going to subtract that from, well, this is just 2/3. We have plus 1. Okay, so when I simplify this, well, 4 times 3 is just 4 times 3 is just 12. So I take 128 plus 12. So 128 plus 12, that is 140. 128 plus 12 over 3 minus, well, what's 2/3 plus 1? That is just 5/3. So we get, what did I say again? 128 plus 12, that's just 140 over 3 minus 5 over 3. Okay. If we take that, that's just 135 over 3. Okay, which is just equal to 45. 45. Let me rewrite that. 45. Okay, so that's the idea behind the simple arc length.